Yo, 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 what's up? Good morning, good morning. Time for round 2. So, yesterday I had my first stream this year. Started the migration to Unity 6. Partly because I want to do devlogs again and I want the information to be updated. And also I want some of the functionality that Unity 6 has. But that didn't go really well. I didn't know why. I still don't know exactly why. But Fabic pointed out to me that it's a big no to... let's see here. Automatically update the project files with the IDE open. So I redid the migration without the IDE open, and we don't have the same problems as today. So he's probably right. And we're in a good place to continue. Yo, what's up, Catboy King? Hope we have more luck today than yesterday. So, hopefully we can dive into what we need to do today. And as I said before we did the migration, it's probably the renderer features that is going to take the most work to convert. So yeah, I guess we can just jump right into them. Yesterday, however, or when I successfully migrated the project and we had some updates. So what I did this time as well is I just commented out all of the content of the functions so that we had no errors. But we had this warning. The project currently uses the compatibility mode when where the render graph API is disabled. The project currently uses the support for this mode will be removed in future Unity versions. So definitely want to get rid of this. Migrate existing scriptable render passes, i.e. this one, and this one, so the renderer features. Migrate existing scriptable render passes to the new render graph API. After the migration, disable the compatibility mode. So now I'm starting to think that migrating these renderer features is not as easy as changing, what was it, render target identifier to RT handler, or actually changing render target handle to RT handle. There might be more to it, and this seems to be the key. This is not the first time I'm hearing about this one, but I don't have any broader knowledge about it. So let's see, Unity 6 render graph API. Let's start there today. Unity 6 render graph API. Yo, what's up, Norin? Okay, this doesn't bode well. This one we want to check. Okay, so this, and let's take a look at this one as well. Yeah, we're probably gonna read through this one as well. Oh fuck, this might be a good place to start. Northern Dev doing good, released new short yesterday. Oh nice, we'll take a look after the stream. And I'm good as well. A little bit rattled by yesterday's stream and the crashes and whatnot. But I'm starting to get over it. Okay, render graph API. Fuck. I've recently, or it took quite some time to get comfortable writing custom render features and how everything here works. And I felt like I really got a full understanding of it, but now it's time to change again. I'm okay with it. I knew that this was experimental when I started to learn it anyway. So let's see. Hopefully render graph API is here to stay, or this solution, or whatever it is. Render graph API allows you to access more frame resources in your custom passes and share data between passes. For example, you can now get access to the G buffer for your effects. Sounds good. Stricter and safer API. Like, all of this sounds good. Scriptable render pass. Okay. Yeah, we're gonna read through this one as well. Yo, what's up, Calvino? Good fortsättning to you too. Hope 25 is treating you well so far. Hopefully we can do without code samples. Hopefully this documentation is enough. But we'll keep this in mind. This is good as well. Create rendering URP post-processing effect, render feature with volume. Calvino 25 has been kind of chill this far. Nice to hear. Arukanan, how's the snooze quitting going? Slowly but surely better, but I'm starting to think that this might be as good as it gets, because it's been quite a while now. Like 2 months or something like that. Still crave it basically every day. Okay, this post in itself didn't give me that much information. Script will render as this looks exactly like, okay, and then we convert it. What? 1 sec. What the fuck is this? Ah, get the fuck out. Okay, pretty much exactly what we're doing. Exactly. I don't think I'm gonna rely on this one from the start. I'm gonna try and rely more on the documentation, and then we can compare it to where the fuck do we have it? And then we can compare it to, where did this one eventually. Harukan and I stopped as well a few days before Christmas. Nice. How's it going? It's tough, man. It's tough. Okay, let's see. So here we have it, and here it is. So, 1 sec. Okay, so, fuck, am I getting this correct? Record. Okay, I think this is a good starting point. Harukan and headaches and constantly hungry and all that. Yeah, I didn't have any headaches, me personally. I feel for you. But the second part I can definitely relate to. And, like, to be honest, a lot of people, or one usual reason for quitting for a lot of people, not for me, is the economical part, or partly for me, I guess. But to be honest with you, it's been more expensive for me to be snooze-free than it has been snoozing, because I'm just buying a lot of other shit instead. Okay, let's start with the documentation, and we can probably move from there. I want to get, like, I want to fully understand this. I want to understand this as good as I can and make the best possible migration that I can for my render features, and hopefully we can update the if I get the knowledge, we can hopefully update this repository as well to Unity 6, and that's why I want to understand it as well. I want this repository to be a good implementation and not a half-assed one. Okay, benefits, that's probably the same as the post on the forums. Render graph fundamentals. Yeah, let's fucking read through this. It's not that much. And then we have writing. Okay, good. This seems to be, I'm optimistic about this. It looks good. But let's see at what the actual content is. RT handles. So instead of render target handle, we use RT handles. This is something we got to yesterday as well. Compute buffers. Here we use command buffer. Okay, one compute buffers. Yeah, that's probably much like this one, but except for render textures, it's compute buffers. Okay, I get it. Renderer lists represents a set of renderer lists. We actually use in the old solution as well. I'm pretty sure. I'm wondering if we get it from this one, rendering data cull results, that this is the renderer lists. Pretty sure. Yo, what's up, Cooler SK? Oh, if you read the memo, we're doing Unity 6 migration now. But then we're back to water, I promise. Okay. There's no persistence. Okay, so so we don't want to create, I guess then we don't want to create RT handles in the constructor here. We actually want to create it in the execute then, I guess. Or you could create, it depends on what they are referring to when they say no persistency here. It's always about water. I guess it is. On some plane it is. Yo, what's up? Good morning, Geralt. Good morning. Just doing some DF adventuring before returning to my sprite work. DF, are we talking about Dwarf Fortress? Also, happy old new year. Happy new year, man. Oh, nice. I just have to say that there is no persistence. I guess it can mean a lot of things. Of course, it can mean a lot of things, but like I wonder what they mean with persistence, or what kind of stuff. Like I'm thinking. Okay, just one example. If we construct a RT handle in the constructor of this class, the RT handle class will be persistent, but the renderer or render texture it refers to might not. You see where I'm coming from? Like I wonder at like how deep or how shallow does this persistency go? Well, I guess we will find out. Okay. This has a number of implications on how to write shader code and how to set them up. Yeah, this one I'm very interested in. So RT handles, we looked into it a tiny bit yesterday. And I wonder if... So in the old solutions, we do a blit here. and we do it from camera color target to outlines target handle. So we take this one and put it in here, and we apply this shader to it. In this shader, this one is referred to as main text. If we do this with RT handles instead, are we gonna have to handle it differently in the shader code? Maybe. Okay. Three-step process, nice. Random graph execution. I always looked at these renderer features, or renderer passes, renderer features and renderer passes to be somewhere around the same steps. But I also include the constructor, which might be weird. Constructor on camera setup, configure, execute on camera cleanup. Entry point, exit point, and configure, and then execute, this one being the actual execute. Geralt, thank you for the prime. Appreciate it, man. Thank you, thank you. So I wonder what these different, so three-step process. Let's see what the process is this time around. Setup, compilation, and execution. Execute and setup. Let's read. In fact, when we're talking about three-step, render graph execution is a three-step process. Execution, three-step process. But then we're talking about setup and compilation. I don't know if, like, it's a sub-step of the execution. I don't know, it feels weird. Maybe the wording is weird, or I'm just missing something, but we'll see. Okay. Geralt, thanks to your stream, sir. It's an amazing journey. Nice. Appreciate it. And execution. Finally execute the graph. The render graph system executes all render passes that it did not cull in this one, I guess. In declaration order. Before each render pass, the render graph system creates the proper resources and releases them after the render pass later. Okay, so this is because a graph can change dynamically from frame to frame, for example, depending on actions of the user. What the fuck? Okay, so this is actually frame by frame. So every frame, okay, am I understanding this correctly? We do setup, we do compilation, we do execution. And that's because we can dynamically change. But if we have one renderer feature we know will be static for the entire game, can we mark it as static too? Because I wonder, like, do we really need to do... If it doesn't dynamically change from frame to frame, do we actually need to do all of these 3 steps every single frame? That doesn't feel very good. But once again, I'm just spitballing here. I don't have that much knowledge of this one yet. That's hopefully what we will be getting today. I'm just questioning it. Okay. Initialization and cleanup of render graph. To begin, your render pipeline needs to maintain at least one instance of render graph. Main entry point for the API. This is the main entry point for the API. You can use more than one instance of a render graph, but be aware that Unity does not share resources across render graph instances, so for optimal memory usage, only use one instance. So I guess we want one my render pipeline for the project, and then the different render features. I don't know what to call them these days, but each render feature will call this one, I guess. Or this one will create the different render features. I have no idea. We've panel in the SRP debug window. Okay. Okay, so we want to do one my render pipeline and we want to do multiple render graph. Yes, okay, I get it. Okay, I get it. But now I'm starting to think that we won't be able to utilize... I really liked, if we do rendering, we do forward rendering. So here we have universal render data. We have some settings that are default in Unity, and then we have our custom render features. I really like having it like this, add render feature and so on. I'm slowly getting the feeling that we might need to move away from this, but I don't know. Universal graph. Render pipeline global settings should be edited from project settings graphics. Where do we have project settings? Oh, we have it here, graphics. Pipeline specific settings. Oh, okay, so this is probably where we have it. Ooh. Default volume profile. Why do I have it here? Let's put it in settings. Can I remove this one then? Can I remove this one eventually? Maybe. Pipeline specific settings. On the currently assigned pipeline for the project. Okay, we're not gonna use these anymore either then. This one, for instance, forward runner. Okay. Render graph compatibility mode. Yeah, when enabled, URP does not use the render graph API to construct. Yeah, so this is exactly the same thing, or the same. This is the thing we're trying to fix. And we want to remove this one eventually. I wonder if we get more options here. I'm thinking of, can we just do, okay, if we jump to the forward render and I don't know, do we have any, fuck it. We just remove these two. And then we do, I wonder if I will regret this. And then we do, after the migration, disable the compatibility mode in edit, project settings, graphics, render graph. And then we disable this one. And what happens then? Yeah, I don't know. But okay, so this makes me wonder, like, where do I get this functionality these days? Or is it the same functionality? I guess we will get to it. Yo, what's up, Sam Smite? Didn't know you use snooze. Yeah, I used to. Not anymore, though. Probably will again in the future. I don't see myself not using it forever, you know? I just want to try, see how life is without it. Sam Smite, I quit snooze quite organically when I took one that was way too strong for me and felt super nauseous. I wish I had the same experience, because that have happened to me many times, but I still continued with it. But yeah. Fuck, I don't really want to market nicotine, but I fucking love nicotine, man. Okay, so we need one render pipeline, and then we do each effect in render graph. Okay, so I'm keeping this in mind while we move on. Starting a render graph. So render graph is the equivalent of render feature this time around? Question mark. We'll see. Begin recording method. Or actually, so we have a render feature in the old solution, and a render feature has this one here. This is where we add render passes to the render feature. And then we have render passes. So we had render features that has renderer passes. And now I'm wondering if we have a render pipeline that has render graphs that has render passes. Begin recording method. Once all the render passes have been added to the render graph, you can execute it by calling end recording and execute method. I guess the people that only want methods to do one thing and one thing only doesn't really like this one, because I guess we're end recording and executing. But yeah, whatever. So render graph params, scriptable render context, render context. Command buffer CMD, so we're still doing the command buffer, current frame index, begin recording, add passes here, end recording and execute. What the fuck? And from a macro perspective, or if we move upwards, like where in this one does this one fit? I don't know. Okay, so when they are talking about... okay, so previously we had, or in render graph fundamentals, I think, we had one point that was we don't have any or a render graph don't have any persistency or any variables that are persistent between render graph executions, which makes me think that, so if we want any of those, they told us to, or the documentation says that we should instantiate them outside of the render graph and send them in. So I'm thinking then that we instantiate, or you usually instantiate them in my render pipeline or the render pipeline, your subclass of render pipeline, and you send them in somewhere around here. And that's your so-called imported resources. And then within your custom render graph class, if we have one of those, or now I might be assuming that render graph is the equivalent of render not render pass, but render feature. So I'm gonna wait with that, but yeah. But okay, imported resources, internal resources. Yeah, but I get the feeling that we must, in some way, we should be able to define and instantiate our own internal resources. So yeah, I will see. After you create or import a resource, the render graph system represents it as a resource type specific handle. Oh yeah. Texture handle, so RT handle, buffer handle. Texture handle. Is this a mistake? I'm thinking that they really want to say RT handle here, but I don't know, maybe. But let's add it as a note. let them know. But it might be correct. I don't know. Just want to make a note of it. Because this is the first time I'm seeing texture handle, but this is also the first time I'm reading about render graphs, so yeah. What made me react on this one, however, is, so here we have texture handle, buffer handle, renderer, list handle, is because somewhere we read about here. The resource types a render graph manages are RT handles, compute buffers, and renderer lists. So pretty much exactly the same as these, except for buffer, renderer list, and texture handle here. Yeah, I will see. But yeah, okay, so this is how we handle the actual resources. We don't handle the renderer texture ourselves directly. We do RT handle or buffer handle or whatever. Which it's not that far from what we're already doing or what I'm doing in my implementations. If we take a look at, we didn't work with a render texture directly, we had a render target handle. Although we did get temporary RT here, I don't know how I put it in this one. I don't know how directly they mean. Camera call, yeah, maybe here. Camera color target, render target identifier. Yeah, I don't know. Fuck, here they actually have texture handles, so yeah. But what the fuck is a texture handle? Unity 6 texture handle API. Here we have it. So that makes me ask the question of what kind of difference between texture handle and RT handle do we have? Cast to render texture. Please operate cast to RT handle. Okay, so what's the difference between... So texture handles should not be used outside of the context of the render graph execution. Maybe RT handles can. For example, textures could be created, the render graph. Could be created by the render graph that are only referenced by passes that are later called with when executing the graph. Maybe. By. Does that make sense if we add a by here? Yeah. Such textures would never be allocated as actual render textures. Texture handles are only relevant to one particular record plus execute phase of the render graph. Okay, so this, I think this needs to be underlined. I need to remember this. After execution, all texture handles are invalidated. The system will catch texture handles from a different execution of the render graph, but still users should be careful to avoid keeping texture handles around from other render graph executions. So keep texture handles as a purely internal resource. Texture handles do not need to be disposed/freed, because I guess the type is like it's implicit from the type that it is automatically disposed and freed. The render texture they represent are either freed by the render graph internally. Yeah. I would love. Fuck it. Maybe I should add some questions I want to get to the bottom of eventually. Appendix. Questions I want answers to. So questions I want answers to, but the answers can wait a bit. And I want the difference between Norin Dev stand-up time by. Good luck on the stand-up, and thank you for dropping by. Difference between texture handle and RT handle. Yeah, very important. I'm starting to think, do I dare guess one more time? I wonder if texture handle is what you should be using these days and not RT handle, but RT handle might be something. Like, I wonder if RT handle replaced render target handle and now texture handle replaces RT handle. But I don't know. Render graph, create texture, create compute buffer, create render list. Never mind. Texture handle render graph, import texture RT handle. Okay, so then my next guess is, I don't know if I should continue guessing, but something I mentioned previously, texture handle, RT handle. No. Texture handle, RT handle. Because import texture. Oh, whoa. Here we have render target identifier as well. Or still, this could still be. Fuck. I don't know. Buffer handle, compute buffer. Yeah, maybe. Note that the specific function to use to import the camera back buffer is render target identifier. So we're talking about this one. So when we want to do, could it be camera color target, render target identifier? So either here, yeah, probably here. Here we want to use, so when we create our camera color target, one sec, I'm not sure. But we will probably be interested in getting the camera back buffer, and then it's important to do it by render target identifier. So we're going to do import back buffer. And here we have the camera render target identifier, maybe. Search as a parameter. Clear buffer. There are also two notions specific to textures that our render graph exposes through the texture description constructors. XR ready. This boolean indicates to the graph whether this texture is for XR rendering. If true, the render graph creates the texture as an array for rendering into each XRI. And dynamic resolution in well, it needs to dynamically resize. Okay. So this is pretty much, it feels like this is where the path splits in two. Like it feels like I'm gonna have to decide, not really, but this is where you want to decide, should the resolution of the game be changeable without a hard restart, or should I dynamically be able to change the resolution of the game? We're gonna have to depending on what we choose, we're gonna have to alter some stuff in the render graph, I guess. You can create resources outside render passes inside the setup code for render pass, but not in the rendering code. Rendering code execute method, question mark. Okay, this is very important. Creating a resource outside of all render passes can be useful for cases where the first pass uses a given resource that depends on logic in the code that might change regularly. Okay. I don't know. I'm gonna be quite bold in some of the statements I make here, given the lack of knowledge for the render graph. But I'm questioning if this is a good example. Both of these passes write to the color buffer, but Unity only executes one of them depending on the current rendering path chosen for the camera. Okay, maybe. I guess if the camera can switch. But that's true. We might have different cameras. Okay, it's a good example. I accept it. Creating a resource inside a render pass is usually for resources the render pass produces itself. A blur pass requires an already existing input texture but creates the output itself and returns it at the end of the render pass. Note that creating a resource like that does not allocate GPU memory every frame. Instead, the render graph system uses pooled memory in the context of the render graph. Okay, I think this is going to be quite nice. But, okay, so when we're talking about this in the scope of my create scene texture and outlines renderer feature, renderer features. So when we talk about this, let me rephrase that. When we talk about this in the scope of our create scene texture and outlines renderer features, so our scene texture renderer feature, it creates a scene texture. We have this functionality in Unity. I just have my own implementation because we want to do some weird stuff with it. Mostly we want to have more control over the MIPS, I think. But anyway, so we create this texture here and we put it in this RT handle. We blit the camera color target to scene texture target handle. That's what this render feature does. But this texture then should be available outside of this render feature later on, because we want this, like, we want to be able to we want this as a global texture for all shaders to use, and we have the same with the outlines render feature with this one. So this is pretty much a texture that has our outlines data, or not outlines data, but our outline information, like which pixel should be an outline and which should not. This one also needs to be available to all shaders as a global texture, but in this implementation, outlines data handle is also a global texture that is available for all shaders, but this one doesn't need to be a global texture. So maybe when we rewrite this one, we do this one as an external resource, like, or imported resource. We want to write to this one, but this one we can do as an internal resource. So we create the outlines data texture inside the render graph. We render all game objects, the relevant game objects, to that texture. And then we use that texture to generate our outlines and write the output to this one. And then when we leave the render graph, we automatically dispose of this texture. I think that's what we want to do. Okay. So I'm wondering if this is built like this because, yeah, okay, we might have 5 different render graph effects or render features. All of them internally uses some form of render texture with the same size, and instead of creating 5 different render textures, the compilation phase will make it so that they all reuse the same render texture, maybe, I think. Yeah. Yeah, I'm a little bit. I wonder about creates a whole new output here as well. It creates the output. I wonder if we send in a texture, so we have an imported resource, and then we write to that one. I'm a little bit. I just wonder about creates a whole new output. What does this actually mean? But let's see, writing a render pass, this will hopefully be helpful. You write a render pass in 2 parts, setup and rendering. I looked at all of these 3 as setup previously, and this as rendering. And then we had an on-camera cleanup as well, but yeah, let's see. We don't need this one this time around because that's things created inside of the render graph automatically gets disposed of, maybe. Setup and rendering. During setup, you declare the render pass and all the data it needs to execute. Render. my render pass data, parameter, texture handle. Okay. Input texture, output texture. Okay. So all of this is set up. After you define the pass data, you can declare the render pass itself using var builder render graph. Okay, so this variable, what is this supposed to be? Is this code supposed to be located in our render pipeline class? If so, we have m render graph here. We don't have render graph like this. I don't know. Render graph. M render graph. Do I want to make the assumption that this one is supposed to be m underscore render graph? I will see, we'll see. Add render pass, my render pass data. My render pass data, so that's this one, and out var pass data. Is pass data, is that a instance of my render pass data? Probably. Pass data parameter, pass data input texture, builder read texture, input texture. Output render graph, create texture, new texture. So here we create a new texture, and this is a texture handle. Output. And here we decide the color format for it, and so on and so on and so on. Now we do pass data dot output texture builder write texture set render func. Okay, you define the render pass in the using scope around the add render pass function. At the end of the scope, the render graph adds the render pass to the internal structures of the render graph for later processing. At the end of the scope, the render graph adds the render pass to the internal structure. So the build variable is an instance of render graph builder. This is the entry point to build information relating to the render pass. There are several important parts to this. Declaring resource usage. Declaring the rendering function. So that's this one, right? But declaring resource usage is this. This one. Do we declare this one? Creating transient resources, transient or internal. Yes. Outside the pass where you declare a transient resource, the handle to the resource becomes invalid and Unity throws error if you try to use it. Okay, makes sense. are all of these... Are we creating any quote-unquote transient resources here or internal resources here? Because I'm wondering about this one. Output texture, it pretty much implies that this one is available outside. Maybe we'll get to that. Maybe all of these are internal and we do something in my to this one in my render func to be able to return it. We'll see. We're going to use a lot of temporary buffers, or we do use a lot of temporary buffers in our render features, so we will hopefully rely on this one quite a lot. The pass data, this one, yeah, is an instance. You probably need to declare the pass. This is where you set the data that the rendering code can access. Note that the render graph does not use the contents of pass data right away, but later in the frame after. Okay. This means that any reference the pass data stores must be constant across the whole frame. Otherwise, if you change the content before the render pass executes, it does not contain the correct content. Okay. It's best practice to only store value types in a reference stays constant until... Okay, okay. This means that any reference... Okay, okay. I guess the reference can be the same, needs to be the same, but the content could be different. I'm wondering if... we'll see. We'll get to it. Read texture, write texture. Okay. Declares that the render pass reads from the input texture you pass into the function. Declares that the render pass writes to the input texture you pass into the function. Same as write texture, but also automatically binds. Can we... fuck. Okay, this is gonna be... It's gonna be messy as hell, I think, but we'll see. Beautiful. Create a transient texture. This texture exists for the duration of the pass. Beautiful. So when we create outlines data handle, so this one, we probably want to do it as a transient texture here. I'm pretty sure. Because we want to create it during the render graph, or during the pass. We render all the objects that should be outlined to it, and then we use it to create our outlines texture. Mm-hmm. Okay. Delegate void render func pass data. Pass data, render graph context. Where pass data class, what the fuck? Okay. You can either pass a render function as a static function. I'm very much looking forward to doing this rewrite of my renderer features. I think it's going to be very fun, but I also think it's going to be very brutal. I think there's going to be a lot of problems. But let's see. Note that if you use a lambda, be very careful not to capture any parameters from the main scope of the function, as that generates garbage, which Unity later locates and frees during garbage collection. Yeah, we definitely don't want to do that. If you use Visual Studio and hover over it tells you if lambda captures anything from the scope. Avoid accessing members or member functions because using either captures this. Okay. The render function takes two parameters, data and render graph context. Here we have a command buffer from this one. Okay. And I wonder, scriptable render context. Do we? Yeah, we have this one here as well. That's good, because then we can get. Okay, so it's this. Yeah, this one wanna. So we get the command buffer. Or did I read that correctly? Yeah, we get the command buffer and scriptable render context, much like this. Or here we create our command buffer, actually. But this time around we might be getting one. So yeah, we can still do this. Okay. Good to know. Accessing resources in the render pass. Inside the pass data. Okay, so pass data, that's where we want to have all our data we're going to use. So I wonder if outside we want to store, so for instance, we use camera color target and camera depth target here, that we might want to store those. We might want to have a reference to RT handle as well. Yes, okay. I think it's becoming clearer and clearer how we should go about this. Yeah. The render graph context also contains the render graph object pool. This class helps you manage temporary objects that you might need for rendering code. Not to render code, but rendering code. Okay. Get temp array and get temp material property block. Okay, let's take a look at this example. Texture handle. Texture handles should not be used outside of the context of a render graph execution. So when my render pass returns a texture handle, I guess we're still in the context, like on the outside of this render pass, we're still in the render graph context. Okay, so we have a method here that returns a texture handle. My render pass, it takes a render graph. Oops. Texture handles should not be used outside of the context of a render graph execution. Here's our render graph. Here's a texture handle outside of the render graph. I don't know. Or am I misunderstanding something? Or is it still in the context? Let's see. And then we use here's the setup then. This it's not the best formatting here. So this belongs together. So we have using, so this is the setup. Where does the setup end? Okay, all of this is the setup, and we define the rendering function as a lambda in this case. So this is the rendering function, which looks to be part of the, okay. Set render function, it takes the data, it takes the context. This is the code. We don't return anything here, we just execute stuff. But here we return the RT handle or the texture handle output, which we create here. Material property block, set texture, set float, draw full screen. CMD, draw full core utils, draw full screen, CTX CMD, data material property block, core utils here. Okay. Okay. I have a little bit of a better understanding about all of this right now. Not as much as I would hope, though. RT handled system. So what is this? Is this something entirely different from render graph this time around? And when we define, so many questions. Like when we define a render graph, how do we define where in the pipeline it should execute? Okay. Cooler SK questions ask him of ChatGPT. Do ChatGPT have this information? It's pretty recent. We're talking... okay, it's not that recent. 2023. Ask ChatGPT if it knows that. Yeah, maybe I should. But what the fuck? Like, are we doing render graph here? Because here we're using scriptable render feature. Oh, one sec. Render list pass, scriptable render pass. I don't understand. Or are we... okay, so here... me... yeah, I'm wondering if... this looks a lot like it did previously, but just with the render graph nestled in between the lines pretty much. I wonder if you could do it like purely a new way. Because if we take a look at migrate existing scriptable render passes to the new render graph API. 36 minutes ago. That's pretty cool. Yeah, I'm wondering if I'm my way to like. I wonder. Jesus, holy fuck. So no. Okay. Okay. Okay, I have the feeling that I want to move away from from these two. I want to do this instead. Yeah, okay, so this is the old one. Let's see if someone has an example of that one. Okay, this is a little bit. Yeah, I'm thinking like instead of the when we're done with converting these to Unit 6, like this looks the implementation here looks a bit too much like it previously did with render features and render passes, but you have the static method here, the render graph execute pass, and you also have record render graph here. So this one and this looks to be related to the new way of doing things, while this and this is also the new way, but so it looks to be the new way but repackaged in the old way. I don't know. Like I'm a bit more confused here. Jesus, I might need to write or read this whole thread, honestly. What the fuck? Ooh, a new tips and tricks, a compact upgrade guide to URP render graph. A project that is upgraded to Unit 6 will automatically turn on compatibility mode. To simplify the upgrading, compatibility mode is not intended for shipping your projects. Once you get your project working in Unit 6, as the next step, you should turn it off and convert your scriptable render pass and render features to render graph. Yes. Yes. If you have a custom pass, there needs to be using render graph. Okay, let's look through that one soon. Implement record render graph for each of your scriptable render pass. So yeah. But I just don't want to add this method pretty much to my custom render features. I want to implement this the correct way with render graph with no reference to the old system. Like if you take a look at it, I want everything to be new, because I'm wondering like how excited to do this in the new system and stuff like that. I don't know if it makes sense, but yeah, we'll see. Modus op URP will not call the scriptable render pass setup execute methods. Instead, it will call record render graph for each pass. Yes. This is literally 1 hour ago. But okay, I would like to have examples of like if you write a quote-unquote render feature in this new system with render graph, how would it look? So I'm not looking to see a solution of converting something from the old scriptable render pass to the new render graph based. Like I want purely new. This one we have red, I think. Or have we? Yeah, let's take a look at this one soon. Don't want to do that. European render graph samples. This one we might want to look into. Okay, I want to take a look at this soon. But let's save all of these eventually. Let's see, render graph sample. Okay, so let's do this. Then we do and I also want to have this one. We're gonna save it as okay, good to have, good to have. Tips and tricks on not to use universal camera data camera target descriptor. Use resource data xxx to get descriptor. Okay, this one I might need to keep in mind. Local versus global textures. Oh, hey. Texture handles versus RT handles. Let's copy link address and look at this. That's exactly questions I want answer to. Beautiful. Beautiful. Lobrazo, what's up? Hi, I don't know if you see that I made a tutorial based on yours for the outline effect. It concerns the update of the code for Unit 6. Hope you're okay with that. You are credited in the video. Yo, what's up? Yeah, I saw that. I appreciate the credit. And nice job, nice job. I'm actually sitting with pretty much the exact same thing here right now. Trying to convert these to Unity 6 and trying to gather as much knowledge as I can. Because this is not just about transferring it or migrating it to Unity 6. We're also going to do some additional render features eventually. But okay, so that's nice. Okay, this is good. This is good. But once again, I want to know, I definitely want to know if this is possible or not. So like, URP package samples show how to implement render graph and compatibility mode in the same pass and share code. I want to get to the bottom of if it's possible to not do it with this approach, if it's possible to do it with purely a render graph approach. Like, best case scenario, I want to get rid of as much boilerplate here as possible. I want to get rid of pretty much all of this. I want to do it in purely render graph if it's possible. Like, it feels like every solution I see is just some small alteration of the old implementation to make it work with the new implementation. This one we're probably going to read this full one. Add a render feature to URP renderer. So actually, is this is the old way of doing it. Do we do it the same way in Unity 6 then? Whoa, whoa, whoa. Is this documentation correct? Render objects experimental, Unity 6. Are we still working with experimental stuff here? Or is this just... the old way of doing it? GG Sammy, what are the benefits of upgrading to Unity 6 at this stage of your project? Honestly, I'm doing it mostly for... I'm planning on releasing new devlogs this year, and I want the information in those devlogs, because I want my devlogs to be tutorial-ish, tutorially. Like, I want to present information in those devlogs that other people can use, much like my outline devlog, cell shading devlog, and I want the information to be relevant, and that's why I'm upgrading to Unity 6, right? Mostly. But after having read through the documentation for RenderGraph, the new RenderGraph API, it seems like I'm gonna gain some performance as well. So, to answer your question short, mostly because I want to make videos where my information is relevant and new, and also to get some performance, you know. Lobrazo, RenderGraph is not experimental as far as I know in Unity 6. Yeah, that's my understanding as well. I'm just wondering, when I read this documentation here and we go through this example, and they have render objects experimental here as a render feature, this makes me think that this is some old stuff. If we go to 22.1, maybe we don't have the exact same, but like, this reminds me of stuff I read about render features when I started working with render features in Unity 21.2. So this doesn't seem very Unity 6-ish. Hopefully, if we do render graph system in URP, this one I'm mostly interested in. GG Sammy, that's a good reason. I love your devlogs. Thank you. Best I've found for shaders online. Oh, thank you. Makes me happy to hear. Hopefully, I can do some new shader-related devlogs this year. Here, add the custom render pass to URP's frame rendering loop by creating a scriptable render feature or using the render pipeline manager. So this is where, okay, now it's starting to make a little bit sense. Creating a scriptable render feature, that's what we did previously in 21.2. That's this one. And in this one, we add passes, right? So this is where I'm getting at. This is the old way of doing stuff. This is how we did it. So add the custom render pass to URP's frame rendering loop by either this or using the render pipeline manager API. And I'm thinking that this is the new way and is going to be the way moving forward. And that's why I want to implement my render features not as this, but as this. Hope it makes sense. Lobrazo, yeah, I struggled too with documentation. That's why I ended to download the URP render graph samples. Yeah, I will probably do something similar as well, but like, I don't want this. I want this. So we can probably take a look at these samples eventually. But also, like, the documentation should be the correct, most recent information. So that's why I like to rely on that one instead of samples. But yeah, sometimes that doesn't really work out. But okay, so we want to do this. This. So this one, okay. To create a code for a custom render pass, write a class that inherits scriptable render pass in the class. Okay. That makes me wonder... I don't know if we do that in this case. Very interesting. Maybe. So I don't want to do this. Probably want to do this. Why wouldn't I want to do this? Like, I don't like this at all. Okay, so maybe I was wrong and this is how we want to do it. But it's gonna be messy to migrate this. So do you have a full-time job next to your video and personal project? No, I have a part-time job. Blit in URP, so Blit has changed as well. Blitter.blit, whatever. The render graph system is a set of APIs you use to create a scriptable render pass. Yeah, so this is what we want to do. I'm just wondering, do we need to package this inside of render feature? That's what I don't like. Lubraso custom render paths are inside render feature. Yeah, that's very similar to how we had it previously, right? We have a scriptable render feature, and then we have our passes here, and we enqueue them with this one, so right here. I got the feeling that we would be moving away from this type of stuff here. So for instance, where do we have it? But we'll see. Yo, what's up, Meister K? Hope 25 is treating you well so far, and thank you for the Prime. Appreciate it. So here, for instance, merges multiple render passes into a single render pass. How is that possible if we have multiple passes enqueued by different... maybe it is, maybe it is. But it's a bit messy, you know? So if we have multiple passes enqueued by multiple different render features, but they all get put in the same system behind the scenes. I'll see. I would just like... I would like to see an example of how someone... Let's say that we have someone that doesn't have any information about Unity versions previous to 6.0, and that person implements a custom render feature with purely using the new system. I wonder how that would look. Would you still see the resemblance to the old system with render passes and render features and then queuing and stuff like that? Or would it look more like this class defined and then you have multiple such code blocks? That's what I'm wondering. Write a render pass using... Pass data, execute pass. Here we go. Fuck, here we go. Maybe. Yes. Lobrazo, yeah, the main difference is the execute pass part, but you still create passes and enqueue them in a render feature. Yeah, that's what I've been seeing so far, but I'm just wondering if that's like a bridge type of solution. So you have both the old and the new system working. So you have the new system working on top of the old system, but if you didn't... Like, I'm wondering if... Would there be a difference between an implementation where you take an old implementation and rework it to Unity 6? Would it be any difference between that implementation and a implementation where you just begin from or start from scratch implementing a render feature? Because if we take a look at this implementation here, write a render pass using the render graph system in URP, we don't have any... fuck here. Additional resources. Example of complete scriptable render example. Yeah, here we still have add render passes, just like you say, and create. We have scriptable render pass, and then we have record render graph. And then we have a scriptable render pass. Lubra, so I really didn't find the documentation clear enough on my side when I was doing my research. Yeah, that's what I'm exactly the same for me, to be honest with you. But if we take a look at this one, so here's the render feature. This one looks pretty much exactly how it did before, right? I'm pretty sure. And then we have a render pass, scriptable render pass. But we have a constructor here. We have a private void update blur settings. When do we call this one? In fact, do we call it in here? Okay, okay. Okay, okay. So this is if we want to work with volumes. But okay, this example might be good. I'm just a little bit sad, honestly, that it looks exactly like it did, but we just flip. We use a few different methods instead, or override different methods. But okay, so we have our record render graph. So this is our setup phase. Right. I don't like this example because we don't have, it doesn't show. Here we're back at it. We should be able to do add render pass. This is what I'm talking about. So here we have a render graph.begin recording, render graph end recording, and execute. This seems to be an entire different way of doing it, doesn't it? Here we have render graphs. Okay. And yeah, so the difference here is configure, execute. Yeah, we don't care about those. Okay, I think I'm starting to get it now. Not entirely just yet, though. Honestly, it felt a little bit clearer having just read this one. Relying on lambdas and stuff like that. Okay, but let's see then. Let's jump to, where do we have it here? Look at the code here. Yeah, we already have that one open, but let's jump to this one. URP render graph samples. Blit renderer feature. So we have blit renderer feature, scriptable renderer feature. Blit data. What the fuck am I looking for? Execute, pass, dispose. Then we have blit start render pass, blit render pass, blit end render pass. These render passes are extremely small, very, very compact compared to previous pass implementations. Set up here. And we have create and add render passes. So this one and this one, the same as previous. So what's the deal with... Blit data. Where do we use this one? blit data here. Here we can see that we have here we have the past data. Here we do record blit color. Here we do the add raster render pass with the pass data, and here we do set render func, execute pass. Here our pass, record render graph. Here we create blit data, the one we have up here. Look at this. This pass, blit start render pass. Here we have record render graph. Render graph frame data. We override this one. Yeah, we need to. What this one does is we create frame data. So context container.create blit data. And this blit texture data, on this one we do record blit color. Record blit color. It's this one. And in here we do... Fuck. Texture is valid. Contains the color buffer from the most. Okay. There might be a more simple example than blit render feature available, because this one is quite intricate. Okay, but if it's valid, universal camera data get. Okay, so that's how we get the camera data. Love it because I need it. And how we get the camera target descriptor. Beautiful. We change the... Okay, so this is pretty... We definitely want to do something similar to this. Then the init... Let's see if we have a little bit of a simpler example here. Blitz should be extremely simple though. Gbuffer visualization. Short and nice. Let's see. Scriptable renderer feature. And here we have create and add render passes, just like we did previously in 21.2 and other versions. Yes. And then we have the scriptable render pass. Yeah, we have some properties. And here we have private class pass data. That's very nice. So here we have texture handle material. Then we have setup. I don't even know. Yeah, we call setup here. So before we add it. Okay, beautiful, beautiful. Static void execute pass. And then public override void. Okay, this is probably exactly how I want to do it. Okay, this is going to be very interesting. So this is the render func, and all we do here is we just loop through data gbuffer length and we set it in the material here, and then we draw something, whatever. Record render graph. Okay, I think what we're gonna do now is thinking about, we're probably just gonna duplicate this one and maybe I just want to start from scratch. Basically, we're gonna have to take this one, this one, this one, this one, and this one, and cook it down to basically two methods. One being a static execute method, and one being an override of record render graph. And okay, we're gonna get to this. I'm just gonna run and grab some more coffee. Shouldn't take too long, so be right back. 1 minute tops. Okay, back. Let's see. Let's do it like this. Outlines, render, feature settings. I'm starting to think we can probably keep this one. It's just some settings. Render pass event. Yeah, when we want to render this. I don't know if we have something similar here. After rendering the first. We have create here. I'm just doing some fail safing here. We set some shader stuff, and then we create a new pass. But yeah, that's what they do here as well, except they don't send it in like this. They create it like this. Okay, I get it. They do a check, then they do dot setup. I wonder if we want to do dot setup before we enqueue pass. I guess we will find out. So let's do this instead. Oops. Hmm. I think we can keep this one around. Actually, let's do it like this. So this is our new constructor. We do render pass event, and we can do outlines, render feature settings. We can keep this one as well. And then we're going to remove these ones. So we're going to have a constructor that is compressed like this, much like and maybe they don't even define a constructor here. They have setup later on, which makes me wonder why not have. They could have a custom constructor without just merging setup and the constructor, right? Or actually, no. Never mind. No. Because maybe they want to create it here. What do they want to create? Okay. Pass data. Execute pass. Okay, execute pass is probably going to be our... It's going to be execute here. We probably don't need to do execute command buffer and clear and all those things. But we need to create draw settings. Because this is where we use shader tags. So this is pretty much where we, for all the objects that wants to be rendered with outlines, they have a separate shader pass called outlines data generation. Let's open up, we can open up cell shade lit. So all objects that should be rendered with outlines has a separate pass with light mode outlines data generation. And this is where we output the data we want. So for our outlines renderer feature, when we execute here, we want to set up draw settings with this shader tag. So we want every material that is visible with this render pass to render. That's what we do here. We draw all those objects. And then we take the camera color target. Feels a little bit, yeah. So after this, we have all the outlines data we want in the texture. So what we do then is we take whatever we have in camera color target. I think we do this because we want the... we just do this because we don't want to do... we pretty much ignore this one in outlines material. We just do this because we need some source texture to be lit. But we do outlines material using this data and we save it to an outlines texture. Then we generate MIPS for it. And then we apply the outlines to the camera color target if we're, yes. Okay, so create the outlines data, create the outlines texture, split the outlines texture with the camera color target. Return. So we pretty much do three things here. And we want to do all of these three things in our execute pass, but this one, so up here we set configure target to be outlines data handle. So when we get to this one, our target, so this one will render to the outlines data. Then when we do blit, the new target is automatically set to this one, and on it goes. What I'm trying to get at is that when we generate the data here, the outlines data we need to actually calculate outlines, this one is this is a internal texture. Like we only use this one inside of the pass. So I don't think we need to do what we did here and define it as a render target handle. Okay, so maybe, just maybe we can start with that. We can start by, yeah, let's try and implement these three. So we start by just implementing this one. When we have that working, we can implement this one. And when we have that working, we can implement this one. So our new, so static void execute as. We don't have a pass data defined raster. We need to include render graph module. Pass data we haven't defined. So this is information we want from outside the pass and we want to use in the pass. Previously we also had, or in this example, they have an output texture here, which I'm still not entirely sure about. This one just draws it. To what geometry? We need to set the G buffer in the pass data. Okay, so what I'm wondering here is if we want to do, let's see, do we want to call it pass data? Yeah, we do. Static void, where do I want to have it? Private class pass data. So what I'm now, when I think about it, we're going to clean this up a bit as well. What we're doing here is pretty idiotic. Instead of doing blit with camera, like we could have done, we draw this one to outlines data target or outlines data texture. And then we could just blit from that one and use main text inside of this one instead. But okay, pass data. So the question is, what do I actually need to send in here that we won't be getting from... we need material... Okay, we definitely want to do this. Okay, so we want to send in outlines material, outlines apply material, I think. Is this how you want to do it? It feels... doesn't feel that clean. But we do want to be able to use these materials in the pass. So here they set up, so pass data material is equal to material. and in here they use it. So pass data, data.material. So that means that the materials, we need to utilize them as a imported resource. Okay, so really what I'm getting at is that we can't use local properties or properties. We can't use these. What the fuck? Yeah, we can't use these inside of the execution. We need to send them packaged in pass data. Okay, so public material outlines material, outlines apply material. I'm really nervous about this shader tag. It's a very nice way of doing it, but I wonder if we can do it the same, like here, if we can do it the same way with the new solution. But okay, we have outlines material. I'm gonna rename it we're gonna name it like this. Calculate outlines material, and we're gonna have material apply outlines material. I think that's a little bit clearer. Could go with outlines calculation. I think this is good. So this material calculates outlines. This material applies outlines. Okay. So we start with these two as pass data. We have execute pass here. Now we have some data here. We're gonna wait with this one because I want to get my record render graph in place first. So public override void record. Is it actually void? Yeah. Record render graph. Okay, so this one, record render graph, it will probably replace on camera setup, configure, and then we have this one implicitly. Okay, so the idea is that everything we set up inside of the render pass will be removed after. Automatically. So we don't need to do this. Okay, so I'm guessing this one, execute pass, is going to replace this one, while this one and the implicit features of this new render pass will replace all the other methods, pretty much. But let's see, record render graph. Universal rendering data. There's a lot of things we want here. If we take a look at okay, let's only focus on draw settings here, or the drawing of the outline data. So rendering normals and color channels, or yeah, render the relevant data to a texture. Then we need to set up that texture, and we're going to do that. But to set up that texture, we need, it's this one we're talking about. Here we have outlines data texture, descriptor. We set it up based on the camera texture descriptor, so we want to get this one, and then we want to change a few things. And then we get a temporary RT here, and we're not going to do this anymore, I don't think. But then we clear target, or we configure target, and then we configure clear. We clear the color, but not the... Now, we don't care about depth here, do we? Now we use the culling results from the camera here. Okay, what I'm trying to get at this time around is that this outlines data render target handle we have here, which we construct in the constructor, or which we instantiate in the constructor, and then configure in configure, or properly set up here. I think we can do all of this in execute. So we pretty much, so for the outline data, we only want to do stuff in execute pass here. Am I gonna show what I think? We don't want any information from the outside, but we do want to instantiate a texture handle eventually. So my question is... Okay. Moving on with that assumption, what do we want to do in record render graph then? We pretty much only want to do... we want to do this first of all. Using var builder render graph.add raster render pass. I want to render graph. Let's take a look at this one. I wonder what the difference between add raster render pass and add render pass. So we have render graph unity, render graph API. Ah, fuck. Don't we have it here? There we go. Methods, add render path, add raster render path. Raster passes can execute rasterization workloads, but cannot do other GPU work like copies or compute. I think we're talking about a raster pass here. Or that's what we want to do. Pretty sure. Profiling sampler, we might want to do profiling sampler used around the pass. Where do they define their empath name? Ah, they just do it here. String. Hmm. Previously we did it like... Yeah, let's just call it outlines for now, or call it outlines for now. We're gonna go with name here. Outvar past data, yeah, because we want to create one of those. Right, why I'm not getting an error here? We define it here as well, yeah. Stupid. Outvar past data. I'm wondering if I want a profiling scope here as well. So, but I don't really know how that would look like. I'm thinking, was it profiling sampler? Profiling sampler. So I'm thinking of doing, because I want to be able to watch this one in frame debug. I wonder if we should do new profiling sampler. Profiling sampler. Profiling sampler is equal to new. And here we do name as well. And then we don't want to send it. Yeah, it's here. So profiling sampler like this. Render graph, add raster render graph, name, pass data, profiling sampler. Okay, pass data. If we just look at generating the data needed to be able to calculate outlines, we probably only need to set... We need to set pass data material here. But that's probably everything. Ooh. Oh. Interesting. Yeah, that's true. Okay, beautiful. So at the end later on, we can wait with this one, I think. But when we finally do this one, the last step, so when we blit to camera color target, that is probably when we need this one. But I don't know. Let's see. Builder use texture. Okay, I get it. So I think we need to, we're gonna, still not entirely sure, but so like if we want to do, we only want to do the outlines data generation. So pretty much we want to do, it's going to look something like instantiate texture handle, because we need a render texture where we store the data, or we need a texture where we store the data, and then render specific objects to that texture. Let's just write it like this. That's pretty much what we want to do. So when we instantiate this texture handle, I wonder if we want to do it here. So we want to set this one up, and if that's the case, then we need to define it in past data as well. So we might need texture handle. I'm making this as a texture handle because this is not something outside of this render pass. We don't want access to this one. We're going to generate this data in the texture, in the render pass, or in this pass, and we're going to use the data in this pass. So outside this pass, we don't care about it. So it's an internal resource which we have as texture handle. I think I'm understanding this correctly. So we do texture handle, outline data, texture. And I think we want to create this one here. But first of all, I want to do the simple stuff here. So we do pass data dot calculate outlines material is equal to settings dot it outlines material here. Let's rename this one to calculate outlines material and apply outlines material. I guess we could probably put, we could have a settings here. Like we could have this struct here, but whatever. So pass data calculate outlines materials is equal to settings calculate outlines material, and then we want pass data dot apply outlines material. Okay, so that's the easy part, I think. So now we should be able to access these two in the execute pass the proper way. So now on to outlines data texture handle. We want to instantiate this one. I think we want to do this in record, much like these do it. I wonder. Render graph, create compute buffer, create texture. I think we want to do this one. Texture handle dot create texture. This one. And we want a texture description here. Very important. Okay, so I think we want to do pretty much. I wonder if we want to do it later. Pass data dot. Definitely want to make this public. Dot outline data texture handles is equal to render graph create texture. And then we want to send in the description. So we want a texture description here. It's going to do it like this, and I want to do it like this. Pretty sure. Okay. This outline data texture. This one is a little bit of a special case because we want to clear the color of it. So every iteration we want to clear the color of it. We want it to be clean. I don't know if create texture does this by default or if we need to send in something here. But we want a render texture that is pure black. We also want alpha to be 0. But not only that. When we render stuff to this one, I wonder. Like when we render stuff to this texture, we want it to take into account the current depth rendering of the scene. So when we render into this texture, we don't want, like when we compare depths, we want to do it compared to what has already been rendered. I wonder if yeah, I'm a little bit worried about this one here. We want to do all of this setup for our outline data texture. I wonder. I wonder if we can get this information. Configure target. Did we have render graph here? Yeah, we do. Add a compute. Create buffer, create rendering lists. Skybox render list. Create texture. Okay, beautiful. Get render target info, get render description, get texture description, get render target info. Okay. Okay. I'm very interested in builder set render attachment. This makes me wonder if having it as one pass, like I wonder what the best approach is. Previously I thought here we just have it as one pass, we do 3 different, it has to be better. Nothing else needs anything of this. Because what I'm wondering, or what I'm a little bit worried about is, okay, so here they do builder.setRenderAttachment. The comment is, for this pass, we want to write to the active color texture, which is, yeah, this is, I don't care about this, but okay, for this pass, we want to write to active color texture. And that's why we do this. Okay. In our pass, we want to first write to first we want to write to outline data. Then we want to write to outline. And then we want to write to active color texture. So we pretty much want to write to 3 different things. So my question here is, does this one set the render target, or does it just prepare these different resources for what they should be able to do? I don't know. What's up, Jax? I'm very interested in builder here. Unfortunately, we have var builder. So let's see what we return and read the documentation. Add raster render. We do render graph builder. Construct. Fuck it, let's do it like this. Render graph, add raster pass, and we get AI raster render graph builder. Let's take a look at this one. Methods. Set input attachment. Use the texture as an input attachment. Yeah, we read about this. This informs the graph that any shaders in pass will only read from this texture. Okay, beautiful. Oh, fucking beautiful. Okay. So what we need to do is, do we have set input? We want to write to it. That's what sucks. Set random access attachment. Beautiful. So it's probably this one we want to do. I'm wondering about this index here as well. Okay, anyway, set render attachments. Use the texture as a render target attachment. Hmm. So what I'm getting at here is we want to instantiate a texture. We want to render to that texture. And then we want to read from that texture. We want to instantiate this texture. We want to render every object in the scene that is going to be outlined. We want to render those with a specific shader, very important, to the texture. And then later on, we want to read from that texture. Previously, we did it like this. We created the texture here. We configured target. We configured clear, and then we did it like this. Boom, bam, done. So now we create it here, and I want to set it up. We create the texture. The graph create texture. Yeah. Then we also want to tell the builder what type. I wonder if we want to do random access attachment. It feels weird. So what did we do here in this example? So we have an input texture and we have an output texture. Input texture, builder read texture. Yeah, builder write texture. Wait, do we even have this one here? No, we don't. Interesting, and that might be because we need to do... So in that case, we might not be able to use add raster render pass, but we need to do add render pass. Interesting. This one returns a render graph builder. So if we take a look at this one, we have a lot more methods. We have create transient buffer, create transient texture, create a new render graph texture resource. Is it that one we want to do? Let's see, what did we do? Render graph create texture. Why don't we have this one here? Add render pass. Add render pass. Render graph builder. Fuck it, let's try it. So instead of doing raster, we do a add render pass. It has to be... Fuck, am I... Let's see here. Yeah, it's render graph.create texture, and then we have builder.write texture. I'm tired. So that one we have either way. But write texture, yeah, down here. Specify texture resource to write to during the pass. So my question is, if we have this texture, so we create this texture, outlines data texture, do we need to do builder.read, or actually we do write texture, and let's do it a little bit nicer. So we do texture handle, outline data texture handles is equal to, so we create the texture, and we're going to create this description soon as well, and then we do builder write texture. We specify this one. Do we need to do read texture as well? Can we do this, or is this like, is this how we're supposed to do this? During this pass, I want to be able to both write to and read from this texture. Yeah, I don't know. Let's see. Read texture. Specify texture resource to read from during the pass. Write texture. Specify texture resource to write to during the pass. Looks all right. So this is the equivalent, not the equivalent, say, but we should have done roughly this. I want to get this texture description correct as well. So right now we just create a texture description like this. I want to create this one like we did here. So that means we pretty much take whatever texture descriptor we have for the camera. Render texture descriptor. We change the color format of it to ARGB32, which it might already be. We want to do some setup here with the description. And I wonder if that's where we need to use universal rendering data. Very interested in this. Extremely interested in this. Unity API. Class universal render data, fields, post-process data. Copy depth mode, default stands depth attachment format, depth primary mode, depth texture format, rendering mode, no methods. One method actually. Create. Not that interesting. Universal rendering data. We just use it here to check which rendering mode we have. Okay, then we have universal resource data. Maybe I'm a bit more interested in this one. Fuck, context container. I'm very interested in this one as well. Yes, let's see universal resource data first. Active color texture, beautiful. Active depth texture, beautiful. They are texture handle. Texture handle. So that's pretty much exactly... Oh! Active color texture... Maybe. We'll see. Actually... Yeah, I think we can use these. To be referenced at render graph past recording time. Okay, beautiful. So these two I'm interested in. Back buffer. Wait, Okay, so this one is very interesting. So we're talking about universal resource data, which we get from frame data. Okay, I want to take a look at this one as well. Frame data, context container. But this camera depth, beautiful. Active depth texture, camera depth texture. Okay. And then I want to take a look at... let's do context container. Okay, so this one is just very generic. Extremely generic. Extremely generic. So can I get some documentation of if we are working with context container in this context, so frame data, like what does this one contain? So from this sample, I know that this one contains... Fuck, we just do get, we don't even check if it contains it or not, right? So from this sample, I know that it contains universal rendering data and also universal resource data. But what more? What can I assume that this one contains? A little bit unfortunate, but we can probably use that one. Let's see. So what I want here is the camera texture descriptor. So I wonder if I can get that from camera color, which is a texture handle. And from the texture handle, we should be able to get the descriptor. And then we can alter it. So it's going to look something like this. Let's see here. We want to get this one. And I don't know why, but we want to do it before using. So we do it here. Resource data. So we do frame data.get universal resource data. We have this one here. And I want to get the description. So outline data texture description. We pretty much want to do resource data dot camera Fuck, there's so many things here. Camera depth texture, camera opaque texture, camera normal texture, active color texture, active depth texture, back buffer color, back buffer depth, camera color, camera depth. Jesus. Oopa. Okay, documentation. What is the difference? Active color texture. This is wrong, I guess. Active color texture returns the current active color target texture. has the same description as active depth texture, returns the current active color target texture. But I guess current active color target texture, current active depth texture, depth target texture, so we don't get that much. Doesn't really tell me anything. The back buffer color used to render directly to screen. Back buffer. Camera color. Main off-screen camera color target all passes. Camera opaque texture. Contains a copy of camera color. I guess we want to go camera color, actually. Main off-screen camera color target. Fuck, I think we want to do active color target. If we take a look at how we implemented previously, we have a configure here, which we get a render texture descriptor sent in here, and this one is a camera texture descriptor. We don't have a descriptor here, do we? No, so we're gonna have to go through this one. So I'm thinking if we want to do active color texture dot texture handle API. Dot get descriptor. Get the descriptor of the texture. Texture descriptor is a struct. Beautiful. So I'm wondering if we want to do it like this. Outline data texture description is equal to resource data dot active color texture dot get descriptor. Oh yeah, we want to send in, so we want to send in a render graph here as well. Okay. So if I just send in this render graph, hopefully what we have here now is a texture descriptor that is exactly the same as the camera output texture descriptor, or more importantly, that is something similar, or hopefully what this yields is a texture descriptor that is similar to the one we got in configure previously. So render texture descriptor, camera texture descriptor, I hope. And what we want to do with this one now is I just want to change the color format to it, or rather I want to make sure that this outlines data texture we create, the color format of this one should be ARGB 32. So 8 bits per channel, that's all we need for this one. I also want to clear it, because we don't want to get old data here. Like, we want to clear this. Every time we use it for the first time, we want to clear it, right? So we'll take a look at that. And I also want to configure target here. This one is, like, we want to write to this texture, and we want this texture to have I'm not entirely sure about this one though. But I think it's important that the depth for the camera, so when we render to the texture and we do depth comparison, we want to do depth comparison with what is already rendered in the scene. Camera depth. So this... camera depth target. Okay, but let's start by doing... So we get this one here, and then we do outline data description dot color format is equal to, oh, are we still working with experimentals here? That doesn't seem, don't like that at all. Clear buffer, fucking beautiful, man. We're gonna take a look at this one, because this one might be what we want. Mm-hmm. Oh, fuck it. I think we want to do it like this. I'm going to show. I think we want to create... I don't know. We'll see. What do we have? Texture disk. Texture handle. I want to keep this one. And we want texture disk, Unity API. Okay, let's do it like this then. Texture disk. Okay. Texture handle, texture disk. What do we have here? Field. We create it from, yeah, whatever, fields. I'm very interested in, first of all, I want to check format, graphics format. Yeah, okay, this might be it. Dot format is equal to, no, it's still experimental. Graphics format. Okay, let's do format dot graphics format dot Unity engine. Like, what I'm wondering is, I don't like this at all. So we're gonna be, like, why don't we have a graphics format? Or like, why are we still using experimental here? Graphics format dot R, I think we want to go with R8, G8, B8, A8. Very interested in. So then we have our texture description. Our texture description has fields for clear buffer or clear color and clear buffer. Texture needs to be cleared on first use. I would love to be able to clear color, but I want to say, we set the clear color. Oh, beautiful. So clear color. So we can set the clear color here, and then so I guess we can do it like this. Description, oops. If we do outlines data description dot clear color is equal to new color 0.0, 0.0, f, 0.0, f, 0.0, f, 0.0, f. So now we have set the clear color here. Will it actually clear it without us setting clear buffer? Texture needs to be cleared on first use. I don't want to clear depth. That's the problem I'm having. I want to clear color, but not depth. Texture handle methods. We don't have, pretty much have nothing here. So for instance, outlines data descriptor dot clear buffer is equal to true. Okay, so we want to create a texture that is exactly the same as, or we want to fetch a render texture or create that is exactly like the active color texture for resource data, but we want the format to be RGB A32 pretty much. We want to clear the buffer and we want the clear color to be 0000. And then we create this texture. We make sure that this is, we let the render graph know that this is a texture we want to be able to write to. And this is a texture we want to be able to read from. Which means that we're pretty much, as we did it previously, we instantiated it here. And then we do this. The only difference is here that we clear only the color here. A clear flag. Don't we have a clear flag or anything like that? We have clear buffer boolean. Don't we have discard buffer bool? Filter mode. We might want yeah, very interested in to see to try this out eventually. But let's just assume that we have everything here done right now. So that means that our setup is done, so we're not going to do anything more here with this one. I don't think we're going to jump to execute pass, but we haven't set up execute pass. So we have pretty much done this setup. Now we just want to set this one. Let's just copy this one. Okay, where do we have the context? Record public. Oh, we call it frame data here. Oh. No, 1 sec. Where do we have context? Yeah, we define it here, right? What am I missing? Set render func. Oh, is it different because of this one? Let's see. Set render func. Fuck, where do we have it? Render graph builder set render func. Render graph context. Should be render graph. Raster graph context. Yeah. One sec, why do we still get record render graph? Oh yeah, because we want render graph here as well. There we go. Something like this. And then in execute pass, we should do, first of all, this. We should have access to... We should be getting a command buffer. We should be getting a context. Yeah, definitely. Draw renderers. Oh, I hope we have something like this. Let's see, execute pass. Context.cmd dot. I wonder if we can do context.cmd dot draw draw renderers. Probably gonna have to do draw renderer list. And then we're gonna have to create a renderer list. And the renderer list, let's see here. Yeah, I think we're gonna go with this one. And then this list we're probably gonna have to create here as well. And this is where we're gonna filter out all the objects based on if they have this shader tag or not. Interesting. This one is probably going to be the... Yeah, it's going to be messy. Unfortunately, I won't have time to dive into it today, but I think, yeah, pretty good progress. I think we can manage to... I think I can manage to fully understand this and convert it in the best possible way this week, hopefully. But yeah, I gotta run now. We're gonna continue tomorrow right from this point. And when we have this outline render feature in place, maybe it would have been a better option to start with create scene texture, honestly. But yeah, we might as well do this one. When we have this one in place, it should be easy to implement this, and then we can move on. Yes, so thank you so much for watching. Appreciate it, and have a great rest of the day. Peace.